Hi students, today let us learn about the chemical properties of metals. So the first one would be reaction of metal with in air. So when we talk about air, we all know that it's a composition of many elements, many gases, nitrogen, oxygen, and some of the halogens and also carbon dioxide, etc. But here we're only going to talk about oxygen because oxygen is the most electronegative out of all of the other elements and gases in air. So the basic reaction would be, or a general reaction, when metal reacts with oxygen, they give rise to metal oxide. So metal oxides, always we have to remember, they are basic in nature. Means when we talk about basicity and acidity, the basic or the general reaction would be litmus test. And with litmus test, we all know that if you take a red litmus paper, okay, and if I dip it in the solution of metal oxide, then the red litmus will change to blue litmus. So the blue color denotes that it's basic in nature. Okay, so all metallic oxides are basic in nature, whereas all non-metallic oxides are acidic in nature. So let us look at some of the examples. Copper reacts with oxygen to give rise to copper oxide. So here, students, we should know that it's a totally oxidation reaction because copper is pure metal. It's reddish brown in color. And once it reacts with oxygen, so copper is undergoing oxidation. Okay, and oxidation means we know it is addition of oxygen or removal of electrons, or also removal of hydrogen also can be called as oxidation. So now here copper is changing to copper oxide. So copper is getting oxidized to copper oxide. Okay, whereas oxygen gets reduced, so that we are not bothering now. It's just looking at the oxidation reaction. Now let us try to balance this equation. So first we'll write down LHS and RHS, and then we will also write down the elements. So we have copper on left hand side, oxygen also, and then again on right hand side also we have copper and oxygen. So first I will write down the elements of, number of atoms of copper. So reactant side there is one copper atom, and on right hand side, that is product side, also I have one copper atom, and it is balanced. Now coming to oxygen, there are two atoms of oxygen on the reactant side, whereas only one atom of oxygen on right hand side. So now it's not balanced. So if I write two atoms of oxygen here, okay, if I write 2 CuO, then what will happen is, now copper is, no sorry, now oxygen is balanced. Okay, now how many oxygens are there? There are two oxygens on left hand side and there are two oxygens on right hand side. But when you see copper, copper is not balanced because I have two atoms of copper on product side and I have only one. So that's why I will write 2 beside copper. So now the balanced equation will be 2Cu plus O2 giving rise to 2CuO. So this will be the balanced equation. So the exam students, you can be asked a word equation and they'll ask you to convert it into chemical equation and then balance. Okay, so please be aware of all the types of reactions which is provided in the textbook. Now similarly another example would be aluminium reacting with oxygen to give rise to aluminium oxide. Okay, so here again, if you observe, aluminum is undergoing oxidation to give rise to aluminum oxide, Al2O3. Similarly, one more example, sodium reacting with oxygen to give rise to sodium oxide. Okay, let's try to balance this equation. We have sodium and we have oxygen. Similarly, we have sodium and we have oxygen on product side. So how many atoms of sodium is there? One atom. And how many atoms of sodium is there on the product side? Two. So it's not balanced. So I will write 2Na. So now sodium is balanced. Two atoms of sodium and two atoms of sodium on both reactant and product side. Now coming to oxygen. How many atoms of oxygen are there? Two atoms of oxygen are there. But here students, how many atoms of oxygen is there? One. So obviously, if I multiply this by 2, 2Na2O. So now it will be, oxygen will be balanced. But If you talk about sodium now, okay, sodium, what happened to sodium? There are four. Now here there are, isn't it? Four sodium, that is two twos are four. But here there were only two. So what I will do is I will change this 2Na to 4Na. So now totally we will just go through this equation again. 4Na plus O2 giving rise to 2Na2O. So now totally how many sodium atoms are there? 4 sodium on both sides. And how many oxygen are there? 2 oxygen on both the sides. Okay. So this way we have to balance the equation. Similarly, one more example we'll take magnesium reacting with oxygen to give rise to magnesium oxide. So here again, if you observe, magnesium is metallic color. Usually it comes as magnesium ribbon, and when it is exposed to oxygen, it will burn violently and also with lot of, doesn't burn violently, but it burns with lot of light and heat. So it's a totally exothermic reaction. And once the product is formed, the product will no more be metallic because now an oxide layer is formed on magnesium. So now the color of magnesium oxide will be amorphous and white color. Okay, so students, all oxidation reactions will give rise to color change of metal. And the most common example is rusting. We already know in rusting what happens. In rusting, we can observe the iron no more has its color. Now it's totally become reddish brown, and rusting also creates a lot of loss for a nation. Infrastructure is totally damaged for that particular nation. Okay, so now coming back to the reaction, magnesium oxygen given us to MgO. So now here magnesium, there is one atom on each side, it's balanced. But oxygen, have a look at oxygen. Oxygen is two atoms on reactant and one atom on product. So if I write 2 MgO, okay, so it will balance oxygen, right? But now coming to magnesium, magnesium is now two atoms on product side and in reactant side it's two. So hence I will write 2 MgO, 2 Mg. So now the balanced equation will be 2 Mg plus O2 giving rise to 2 MgO with each atom being 2. Okay. So this concludes the reaction of metals in air. Next video, I will come with a new topic that is going to be amphoteric oxide. Thank you very much.